and interviewing Ray K. Linsley Jr., is that right?
Yeah, I don't use it, Junior.
You don't use it anymore, you used to, some years ago. I'm on some of his activities. In fact, there's some things I would like to ask Ray because I don't know all of his background myself. I do know he was with the Weather Service for several years, and I would appreciate, Ray, if you might give us a little background on how your career progressed.
Okay. Well, I started with the TVA in 1937, working with the flood forecasting section there.
Oh, yeah.
Then in 40, you got the idea that I wanted to go to law school, even on water law. But other things happened in 40, as you'll remember.
Yes.
And I never got a chance to leave the Weather Service to go to law school. So I stayed with them for 10 years until 1950. And then I took off for Stanford.
You were in Washington, though, for a while.
Well, I was in Washington for a year or so at Hydromet, and I was sent out to Sacramento for forecasting. And then at the beginning of 45, I returned to Washington. And he's in there, the assistant chief of this division of hydrologic and climatological studies or something.
Right.
So that's a governmental name.
And it was, who was in charge of the office at that time? Rob Bernard.
Yeah.
Rob Bernard. Because he was really the first chief of the Office of Hydrology as we know it today. Well, I'll ask you something else. When did Max Kohler come into the picture? Was it about the same time?
It was the early 40s. I can't tell you the exact date. I think he was already there when I came up from TVA.
He might have been. That's very interesting. Did you go back to California, back to Sacramento before you came to Stanford?
No.
Oh, you went to Stanford from
Washington. Yeah.
From Washington. It was during this period. That that a lot of the techniques we're using today, still today, were developed, such as the API procedure. Were you instrumental, and did you work on that procedure during that period?
Well, I was working on a number of things when they didn't divert me off to one of the interagency committees or something like that. But Max and I kind of worked together on that and on evaporation studies. And we did the work on the routing.
Yes.
Routing analog.
I remember they had a machine in that one time. It was an analog routing.
Right. And we worked with the instrument division on producing various new instruments. He gave him cards, couldn't give him much.
Not
very much money, no.
Well, then you left the Weather Service then in 1950?
1950, yeah.
And came to Stanford at that time. Well, did you, the program, were you about the first person at Stanford in the field of hydrology?
Yes. I replaced a gentleman who was a sanitary engineer.
No.
Now they call them environmental
engineers. I see. The Did they have a graduate program in hydrology at that time, or were you more or less instrumental in starting that program that evolved?
No program in hydrology.
Had no program.
What we had in the graduate program, I started working with Stan Davis and others down in Earth Sciences.
You're, when in this period did you first start developing what eventually became the Stormford model?
Well, I think we started something in about 56. That's when we got a computer. Or that's Hampshire. And IBM 650, I remember it well. You used to punch up the cards, we'd go over and stick them on the hopper, push the button, cross our fingers. Right. It usually ran. But that time it was very crude kind of stuff, nowhere near what we came to see later.
Mm-hmm.
In about 60 or 61, I've forgotten when the administration at Stanford asked me if I'd do them any good to enlarge the canal which fills Felt Lake under their water supplies. And I said, well, I didn't know. We had a short record on that stream, but I could see that skimming the top off that wouldn't add much water. I said, if you give me $500, I'll get somebody who will work on this for the summer. And we contrived the model that was Ron Crawford, actually.
Was that right?
We did the programming. We decided a rather crude model. And it answered the university's question that wouldn't do them any good to expand canal. And it also inspired me to try and get something better because it was awful crude. I was ready, just patient. You should just take it over.
Yes. Well, Norman, the first graduate student that really worked on the eventually became the
Yes.
model.
Yes. Yeah.
Going back just a little bit further, and we skipped over it, but when was it the first, not the Hydrology for Engineers, but you had a first book, which was a big, thick book, which was called Applied Hydrology, yes. When would that come out?
49.
In 1949. How did you and Max and Joe Paulus get into that?
Well, Max and I thought it was a good idea. I had a little sailboat on the Potomac at the time, so we got Joe into that. Sailing, and argued him into to join us. It wasn't really much of a job to get him interested.
Well,
Was considerable job to write it. I think we're about 3 years at it.
you wrote it from about 45 to 49, or I was earlier than that.
46 to, I think we probably turned the manuscript into McGraw-Hill in 48.
Did you have quite a bit of encouragement from the Weather Service at that time, or were they kind of blah about the whole thing?
Wow. Well, we didn't really ask the Weather Service. We did all the work on your own. And Will Bernard knew about it. It was very encouraging. But he didn't give us any time.
Didn't give any real encouragement other than the verbal.
Yeah.
Well, when was that came out in 49. The first edition of your Hydrology for Engineers came out when, about 56 or 57?
57.
57?
Sure, exactly.
Yeah. How did you happen to get involved in that then? You were obviously at Stanford by that time.
Yeah, well, McGraw-Hill wanted a little more of a textbook than applied hydrology.
Yeah.
And so they asked if we could produce a smaller book. Even then, inflation was beginning to take it all.
Yes.
And so we did.
And that's when you came out with the 57 version.
Yeah.
Actually, wasn't that, didn't you find that more popular than you really expected it to be?
Yeah. Yes, I'm really astonished. That's sold over 25,000 copies have been tested so far.
That's what I thought. Because there wasn't anything really at that time in that particular area. Right. And you've gone through now 3.
It's in its third edition.
Third edition now. But at Stanford, then did your program once you got into the Stanford model thing? How did that evolve? Did you get a number of students interested in working on this, or?
Well, first up to the version 4, which is the last one that was developed there, Crawford did most of the work, both programming and testing and so on. Mm-hmm. Derek Anderson
I know, sir.
Did a snowmelt model. And other graduate students I used on applications of mine.
Uh-huh.
It seemed to me that it was more than just a model.
Yes.
That in itself was not much of a justification for the whole effort. And so go with friends and Krager and several other people worked on applications
of the model to various.
Yeah. Mm-hmm. Chap with a geological survey now. Used it to make estimates of probable effect of cloud seeding.
Oh, wow. Yes. We did some studies in Kansas, I remember seeing a paper a number of years ago when he made some evaluations of the effects of cloud seeding. If he increased it by 10% or 15%, yeah.
Or randomly. Various kinds of increases.
Yes, I remember that.
You could simulate the flow, assuming a certain set of conditions, and find out whether the volume of runoff was increased. Find out whether the peaks were increased.
Yeah.
Of course they were.
Oh, yes, sir.
And then Delbert Franz got into the business of generating rainfall, hourly rainfall statistically, so we could fill out stream flow records where there was only a short rainfall record.
Mm-hmm. I'm not sure. Was Steve Burgess here at that time?
Yes, but he worked on the stochastic
Oh, on stochastic.
methods, yeah.
Mhm.
Up to that time, applied stochastic hydrology usually meant they were going to run up 100 years of streamflow data and use it in lieu of
Yeah.
missing record. And what he showed was that you can't do it that way. You got to run up a very long sample,
Mm-hmm.
say 1,000 years, and then break it down into short packages.
Yeah. When did you form the company that you had first, that you were involved in for several years? Hydrocomp. Mm-hmm.
That was organized in 1966.
Hmm.
I'd been over in Turkey that summer and I could see that there was need for some kind of modeling over there because there was no records. They were records, but they were short.
Yeah.
And uncertain quality. And so I suggested to Crawford that we start the company.
Was Crawford? He was a member of the faculty at Stanford at that time, or was he?
Well, he was assistant professor.
And you and he were instrumental in starting this group.
Yeah, we were the original founders and the original staff.
Whether
For some years.
Yeah. Simon, would you like to ask that?
You were trained as civil engineer.
Civil engineer,
Worcester?
Worcester Polytechnic Institute.
And you went into hydrology because you joined the weather service?
TVA.
TVA.
Which was really I think the leading agency in hydrology at the time. The Weather Service didn't have much of a forecasting
No.
function at that time in 1937, but TVA had some real problems in forecasting for the operation of our river beds, forecasting for stranding, floating barges off when they ran a current out. And when we weren't forecasting, when we did hydrologic studies for the agency too.
Did you join the Weather Service at Knoxville then, or did you?
No, Washington. I earned it. Well, I got the job while I was in Knoxville.
Yeah.
A partner had wanted me in Washington right away, so.
Didn't going along with this? Did the Weather Service have a forecasting unit with TVA for a while, or did TVA do its own forecasting?
Streamflow forecasting, TVA did its own. There was some kind of an arrangement for weather forecasts.
I gotta say, I think there was a weather forecasting group or something. But all the time you were with TVA, how long were you with us?
3 years.
3 years. Till 40?
No.
These years at TVA were really the great years of the TVA. A lot of good work was done, for example, in flood routing and reservoir operation and so on. Can you tell us, for example, what you remember, the people you remember at that time? The Muskingum method was probably developed around that time or slightly earlier.
The Muskingum method was developed by Chaplain Corps engineers in about that time. And of course, the unit hydrograph had been developed just a few years earlier. That was our main tool at the time with TVA. The people who worked at TVA at the time were Thor Nordenson,
Is that right? Sure.
Bill Ackerman.
Bill Ackman, certainly.
Bill Ackerman was just preceded me at TVA by a few weeks, I think it was.
Yeah.
We all lived in a boarding house in Knoxville. Loaded up. He became quite good friends.
Was Louis Poles there at that time?
No, he was with the Corps of Engineers.
Oh, he was with the Corps. Oh. He eventually went to work for the Bureau of Reclamation. Well, I knew him in Bureau, but I remember he had been in Knoxville or someplace back there. I thought.
Could be. I don't remember where he was stationed. But he did work in
the Corps.
The rivers of the Midwest there. Our tributaries.
What can you tell us about the beginnings of sort of formal hydrology in the U.S.? At one time, that hydraulic engineering, but hydrology was not quite respected profession.
Well, I can't tell you too much, I guess, about the early days. What I know, I learned from reading Mead and Meyer. But about the early 30s, I was still in school at that time, and instantly I didn't get a course in hydrology in college.
Sure, that's true.
And but agencies like the TVA were underway, and they needed really good hydrology, something you could do with methods. Well, there's another common thing is in the rational equation, and that was used for everything in the early days. So at TVA, we had the unit hydrograph, we had routing. Chap in the with TVA named Engstrom did some work on routing too. He had Wilkinson was in charge of the flood river forecasting section there. And he did some work where they released waves from Norris Dam.
Oh, yeah.
And tracked them downstream. Of course, we used any method we could to give us a reasonable answer. There was no worry then about the theoretical concepts. In fact, it still strikes me as a little odd to hear people talk about the theoretical concepts of the unit hydrograph, because what was his name? I can't remember, but what he really stated was, well, if you have one storm of a certain... Sherman, yeah. He observed that if you had two storms that were more or less the same, you got about the same results, which is an obvious conclusion, but it took Sherman to see it.
Yes, unfortunately.
I don't think he had any theoretical background on which led him to that concept. It was just observation. Horton had been, of course, active in a large number of topics, principally infiltration. And we used his concepts as well as we could, but they never worked terribly well. Working with the kind of data we had, all we had was daily rainfall, and you can't do infiltration analysis or daily rainfall very readily.
What did you get data every day from a number of gauging stations? Where did you call in?
Yeah, we had a number of stations, stream gauges and rain gauges. Some telephoned, some telegraphed. Some reported every day, and some reported when the rainfall got above the specified amount.
Criteria. We still do that. Things haven't progressed much for 40 years.
That leads to a lot of interesting things. I mean, I remember one case where they had a report from Upper Tennessee of a tremendous stage, higher than anything that had been reported historically there, higher than anything anybody in the office had experienced. And after rolling it over a bit, we decided the lady there must have gotten off by 10 feet. So we took 10 feet off the stage and went on. By golly, she was right.
Oh, she was.
Yeah.
And it was a high stage.
It was a high stage, yeah.
So you blew your forecast. That wasn't the first Weather Service forecast that was blown.
No, that wasn't the first one. It was hard.
TVA or whatever.
TVA was fortunate in that it had reservoirs which stopped most of the flood peaks, or at least lowered them.
Yeah.
And they were more interested really in how fast the reservoirs were going to fill and spill than anything else.
Were they concerned primarily with power generation, or both power generation and flood control?
Well, at that time, they were concerned mostly for construction because
They were in construction.
they were still in a construction phase.
I see.
They needed to get their crews out of the river bottoms at the various dam sites if something was coming. They were concerned with power, not with flood control, practically speaking. And we had other things like mosquito control. Yeah. I remember spending several weeks trying to figure out how you could lower the reservoirs and then not quite fill them up again. And then a week later lower them and then not quite fill them up again without losing energy.
Oh.
And of course I couldn't prove it was possible to do because I always lost energy when you did that sort of thing.
Well, what was the purpose of lowering them for?
Well, you lowered them about a foot from the day to strand the larvae on the plants, and fill them up slowly over a week's time.
I see.
Hoping the larvae wouldn't survive long enough to be refloated, as it were.
I see. Were mosquitoes quite a serious problem in that
area? Mosquitoes, malaria was an endemic in sea. Is that right? Mm-hmm.
That time. It's interesting. It's hard to realize.
I'd seen people who lived there. Sanitation was not top priority, I'm sure. not trying to say anything against those people. They just left the way they always had.
And they walked the modern cities that they are today.
No, Knoxville was a fair city, but most of the little towns up in the fields are little towns
Yeah.
with no facilities, particular.
Okay, let's ask Ray a question we were asking a minute ago, and that is, how would you happen to get interested in going into the field of hydrology?
Well, I didn't really know there was a field of hydrology until I got to TVA. At Tech, they gave us a course in the use of the ripple diagram for estimating the storage of a reservoir. But I majored in hydrology option in tech. We did a lot of model work. And, I don't know.
Olden hydraulics.
No.
Was it in existence at that time?
Oh, yeah. That was set up by Charles. Oh. Wish I could remember names better than I do.
I have the same problem.
Charles Young.
Alan.
Yeah, he devised the Allen salt velocity and method for rating turbines. And we used to do a turbine rating out at the Allen lab. Took the whole class all day to do it. But it was interesting, and we learned a lot. We had a pond out there with a rotating boom in the middle of it that you could tie
In Bristol?
Yes.
Is that right?
Well,
All right. Okay, we're getting back to where how you got interested in field of hydrology and hydraulic engineering.
well, it was really the work at TVA that got me interested in hydrology. I had majored in hydraulic engineering at Tech and had some work in fluid mechanics and model testing and such. And my first job, actually, after I left Tech, was in New York City at what was then called Phoenix Engineering, which is now Basco.
Ebasco. It happens my son worked for the company that owns Ebasco, InSearch.
Uh-huh. Well, I lasted about 2 months there, and they put me on a drafting board,
Oh, yes.
and I'm not a draftsman. And I got a telegram from Knoxville saying was I interested in working in their hydraulic data division. And I said, yes.
I'd like to know what salary.
$1,500 a year.
Yeah. That's a good salary.
Assistant engineering aide.
Yeah. But this was 1937?
37, yeah. Yeah, that was good salary in those days. It was as good as I was getting at Phoenix.
Mm-hmm.
And I didn't have to live in New York.
Yes. What did you do first when you went to Knoxville? Were you doing hydraulic engineering or?
No, I was assigned immediately to their river forecasting section.
Oh.
And I started out by learning how to do what they did. I guess for a while I answered the telephones, wrote down the reports, but as soon as I knew what else to do, I was on it. And wasn't long before I was on the telephone shift all by myself in the early mornings, many days.
When did you become acquainted with Mel Bernard? Was he he moved into the Weather Service, or he became the head of that group about 37. Boom did.
37, yes.
Mm-hmm.
And I think I finally wrote a letter to him, asked if he had any interest in another employee, and he was very prompt to say yes. Went up to the Weather Service, and I had the Hydromet section was in existence, and
Was Showalter there at that time?
Showalter was there. Can't remember the man who was in charge.
I don't know. Yeah.
No.
Yeah.
Anyway, Frank Snyder was there,
Oh yes.
working in the forecasting methods,
Mm-hmm.
and particularly on that graphical test scheme, which he developed. And I think he had done the work on the synthetic Earth hydrographs and too.
Yes, certainly.
And I spent some time both with Snyder and up at Hydromet doing various jobs. I remember one job, they had a historic flood in Delaware, I think it was, in New Jersey. And there was a record of an enormous boulder moving some distance, and assigned me the job of computing how much the flow must have been.
To put that boulder, yeah.
Yeah. Needless to say, I didn't do a very good job of it. I had nothing in sedimentation at that time. But it was interesting work. And Bernard used to take me to readings halfway of the core.
Hence.
And then when they discussed what was going to happen next at Hydromet. And then finally, Mr. Fetcher, who was in charge at Sacramento, somehow pulled off a request for an assistant.
Oh.
I don't know how he got away with it, because most weather bureau offices didn't have any technical assistants at that time, where I was sent out there. And I learned a lot from Fletcher, but he wasn't about to let me use his methods of forecasting. He wanted me to forecast. So I got broken into forecasting right off the bat, including weather forecasting. Fletcher was not on duty. I would have to plot the map and
Wait, where's that coming from?
Edgar Fletcher, was in charge of the weather office of Sacramento. The Weather Forecast Center was down in San Francisco in those days. And but Sacramento was a river district office.
I see.
And but the only staff there was Fletcher and myself and assistant observer.
Good night.
Who came in and read the various instruments. And so, and he plotted the map most of the time, but often I had to plot the map and make a forecast. The local forecast, of course.
Mm-hmm.
I remember the day, this December 6th, 1940, when I was on duty, and there was a reporter who always came in to peer over my shoulder while I was plotting a map, and he said, "There aren't many stations on that map today." And I said, "No, none came in." And so we put it out in the Sacramento paper that there were no weather reports in that day. And there was a major in charge of the San Francisco office. Next morning, he called up Mr. Fletcher and gave him a sure to help. And of course, you know what it was. It was the day before Pearl Harbor.
Oh, this was 41.
41.
Yeah, yeah. December 1940. Is that right?
Yeah. They shut off all the ships at sea. And we got nothing.
Oh, yeah, sure.
The major was, I think he was mostly mad because he didn't get a chance to disclose that fact to the press.
Oh, I see.
But he really had Fletcher trembling, literally trembling.
Is that right?
So,
Well, that was a river district office, and what did you have the San Joaquin and the Sacramento rivers, or what?
yeah.
And was it your responsibility to forecast the flows on both of those rivers?
Yes. Of course, it was really Mr. Fletcher's because he was official in charge.
I mean, you did the work.
He assigned that work to me.
Yeah, I see.
It was interesting. I had to develop a whole set of procedures. And it was my first experience of really developing something.
Yeah.
Had to make a forecast by 11 in the morning because that's when the newspaper wanted the story. So there was a time between 7 in the morning and 11 when I could try to put it all together and have a forecast ready for the newspaper.
Mm-hmm. Were we getting quite a lot of data up and down the valley in those days?
Not very much. The state had a few, I think maybe 3 or 4 radio gauges.
Oh.
And we had a radio receiver in the office too.
Mm-hmm.
And so we could pick those gauges up. And there was a telemark at Sacramento, which we could get by telephone.
I didn't know we had telemarks then. They've been there a long time.
The state put it in. I'm not sure. And then we had a number of stations which reported by telephone, telegraph, or whatever they could do when they could get through. Mm-hmm. Sometimes it turned out to be by mail.
I bet that was slow.
Well, but a lot of the telephone lines up in that area were just barbed wire fences at that time.
Yeah. How long were you at Sacramento then?
3 years.
Till 44, 45?
Till end of 44, yeah.
And that office was responsible for forecasting the valley, really.
Yes.
Mm-hmm. Did you only have about 3 or 4 people in the office during that entire time?
Well, we never had more than 3 of us.
Is that right?
And the assistant observer quit and got cool. So a new one could be found.
Did you operate 7 days a week? Or did you shut down on Sunday?
Well, we shut down on Sundays if the weather was going to be good.
I see.
We also operated. I was on duty at least over 36 hours to one shift there. And that was a big flood in 42.
I was going to say, I think 42 was a big flood year.
It was a big year. We had that was the one we had snow in Sacramento.
Oh, no kidding.
Roof failure in Sacramento, as a matter of fact.
Is that right?
From snow load. But when it rained, when the snow turned to rain, and there was quite a depth of snow on the lower foothills, which all came off for the first part of the rain, created a fairly decent flood.
Yes.
Well, But it was a very interesting experience. Once a year, Mr. Fletcher and I got in the car and drove up, inspected all the stations.
Oh. So you got to visit all the observers and
We painted the staff gauges that were
need to be repainted.
needed to be painted.
Maybe that's where the tradition of giving a can of paint to, this used to be a standard procedure with our field people. We'd give them a can of paint, a brush, and every time you go by a rain gauge or a staff gauge, paint it.
Well, we didn't do quite that much. But, the Hydrology Network office was established in Fendier. No, here.
Wasn't you with that, an area hydrologist or something?
He was the area hydrologist later, but was no gentleman down there. Bureau of Reclamation, man.
Oh.
The guy that devised the logarithmic plotting. Barnes.
Barnes? Oh, B.S. Barnes. Oh, I know B.S. Barnes, certainly.
You know, he's still alive.
Is he really?
He was at least a year ago.
Is that right?
Up in the North Bay area somewhere.
My gosh, can't believe that. B.S. Barnes. I'll be darned. He must be in his 90s by now.
Yeah, I should think he would be. But he was down there in San Francisco, and he was, I think, called area engineer or something like that, and took over the recording rain gauges, so we didn't have anything to worry about except the non-recording gauges.
Was he with the Weather Service in those days?
Yes.
That I didn't know either. I worked with him for about 4 years. He was in Bureau of Reclamation in Denver when I went there in 1952, and I was there until he retired. He was with the Weather Service at that time.
Yeah.
Yeah. He was a good hydrologist, by the way.
Very good.
He's a good hydrologist. Then you went from Oregon to Washington.
Back to Washington, yes. And, took over the hydrologic side of the division.
Of the division. There was a climate part and a hydrologic part.
Woodrow Jacobs was in charge of
I was going to say, Woody Jacobs, yes. Yes, when did, he died just very, very recently. Climatologist. What's his name?
Oh,
Landsberg. Yeah. He came later, didn't he? Yeah, to the other service.
Yeah.
Because I had Landsberg. I was at the University of Chicago in 1944, and I had Landsberg as a professor there. And I thought he was an old man there, and he died the other day, and he was just 80-something. It's just relative. Yeah.
You said you got interest in hydrology in connection with the ripple diagram, and you learned it by yourself, actually. There were no textbooks on hydrology at that time. You said you read Mead and Myers and so on. What other publications, what other books were sort of useful to you in formulating the hydrology?
Well, the Meister hydrology bank was a
Mm-hmm.
as far as books go, those three were about all that were available. And I still think Mead was an extraordinarily sharp man, considering he had no formal training in hydrology either. But I met him in Boston once at an ASC meeting. And I guess I was still in school, and I guess that may have influenced me. Certainly.
Mead was the book in water power engineering.
It's called Hydrology.
Was hydrology?
Yeah.
What was his background? Was he?
He taught at Wisconsin.
Oh, the University of Wisconsin.
Yeah.
Oh.
Daniel Webster Mead.
As such, then, can you sort of trace the beginnings of formal instruction in hydrology at U.S. universities as a subject on its own merit?
Well, Meade was teaching at Wisconsin about, he must have been teaching there in the 30s. Now, obviously he didn't have much what we call modern techniques of them, but he used common sense, which is an important part of hydrology. And as far as I know, there was very little other teaching of hydrology until I got to Stanford in 50. And I started 2 courses there, one called Hydrology and one called Hydraulic Engineering. And we expanded from there. It was a very instructional period too. I learned a lot. It's remarkable how you can stop right in the middle of a sentence in a lecture and say, "Oh, that's not right."
Yeah.
And that was very good for me.
Were you in the civil engineering department there?
Civil engineering, yes.
And was there a little bit of, sub rosa things attached to hydrology at the time? Civil engineers or hydraulic engineers didn't accept this as a particular discipline. Was there a sort of
Well, we didn't.
effort?
At that time, we didn't have make any speciality of it. The students had to take the hydraulic engineering course, one of the required civil engineering courses, and the hydrology was optional.
Oh.
Stanford had a very heavy course load in the humanities and sciences, and so the technical course load in civil engineering was not only light, only about 30 units open, and out of that would become all of the statics and dynamics, soil mechanics and fluid mechanics, and by the time you got through all of what were on basic civil engineering courses, there wasn't a lot of room for special courses, which was a good thing as far as I was concerned, because it took a couple of years to get a handle on how to teach hydrology. I find students often didn't like it because you couldn't give them an absolute answer. It still is. Tell them how to do it and say, well, that's close, but it's probably not the right answer.
It's still like that. Yeah. Listen, you talked about the unit hydrograph method, which Sherman developed, was used extensively in the TVA. And then the sort of theoretical basis of this came up later on. People tried to prove that there is a theoretical basis of it, and the instantaneous unit hydrograph. Is there really a theoretical basis for it?
I don't think so. I don't think so. It would work better than it does if there were some really sound basis for it. It was a very useful tool, but I always found that the easiest way to use it was to develop your own unit hydrographs without use of a computer, which I think is just a waste of time on that. And use a lot of judgment and how to fit them together.
No, we were. Dave Doddy was giving a talk recently, and he said that at the time that you were working and developing the Stanford watershed model, he and O'Donnell were working at the Geological Survey developing their own model at that time. Was there some conflict there, give and take at that time?
Well, our first model, first version and the second version, were completely before he didn't work. I remember he came around one day to talk with me. He was in Menlo Park, I guess, then.
Yes.
And about modeling. He didn't seem to understand very much about. It takes a lot of getting used to the concept of the hydrologic model. The first paper I gave on that was at a IASH meeting in Berkeley.
Oh, yes.
And I don't think a person in the audience believed me. And some of the questions led me to believe that some of them didn't even think it was possible to model hydrology. And it's been a slow struggle. Now I think the competent engineers use models, not necessarily the Stanford model, but there's several models that of the same breed. The key is continuous simulation.
Yes.
And they all do about the same if they're calibrated against observed data. But the problem still is that it's too much work for most civil engineers. They don't want to go to all that trouble, collect the data and simulate it when you can use the rational equation and get an answer in anywhere from 30 seconds to 15 minutes.
Yeah. That's true.
And I'm still amazed. I'm sure the Irishman who invented the rational equation would be amazed.
I'm sure that's correct.
He came back.
He realized that $1 billion worth of cross-drainage structures and so forth are built every year using his very simple equation.
Yeah.
In terms of hydrology instruction nowadays, how shall we proceed? Where should we go? Where should the emphasis be?
Well, I think the emphasis should be on the applications of hydrology to engineering problems. From my viewpoint, I don't wish to exclude forest hydrology and agricultural hydrology and all those things, which are also useful. I wish that there'd be a little less attempt to make everything a closed-form mathematical solution, because mostly these don't work. I wish somehow we could do away with the PhD system, thereby eliminating I don't know how many attempts to write new models. I agree with that. It can't really do on the bid. I mean, there have been a lot of ROP models written. I, for one, have never felt the Stanford model was perfect. But I haven't seen one yet that's any better. I think there are probably several that are just about as good, including Dottie's model. Probably just about as good, at least under the conditions for which you developed it.
Right.
And, I think we go overboard on the stochastic techniques. And I still cannot understand how anybody can believe that stochastic hydrology will let you do day-to-day forecasting. Because it can't take you any farther than yesterday, really.
That's right.
And well, I think there's just too much of that in the schools today. I get applications even now for people who want jobs with us here in Santa Cruz. And I look at the records, I'm amazed at they think you're waiting for a job as hydrologist, but they're not. They haven't got the kind of stuff that it takes. I think hydrologists need to learn a little bit about string gauging, for example. Not that they're going to do much of it, but you ought to understand the problems. If you go out and make one or two slope area determinations and realize that, and then check them by Ranger and realize that they're not all that accurate. And I always found our best students were men who had worked as hydrologists somewhere and understood the problems and knew what they wanted to find out when they came back. I think we got to have a guts to stand up in class and say what was method tell, say right up that certain methods are not fit for an engineer of any pride to use, including the SCS curve number method. And we have to teach the methods that we know are useful, and not everything under the book, as some of our professors of hydrology try to teach. They go all the way through everything.
Yeah.
And in hydrology for engineers, we don't mention some of the methods that I consider unmentionable.
Yeah.
I don't know whether that's fair to the students. I suppose they should know that such a method exists. But they should also know that it doesn't and can't possibly work except on 100 square feet of concrete peg.
Yes. Somebody mentioned that yesterday about developing parking lot hydrology.
Oh, Dave Doty.
Dave Doty, yes. But I think this is true.
Well, the ones at the MIT people developed this parking lot hydrology. Yeah, parking lot infiltration was involved, and you had just overland routing.
Yeah.
Yeah, most parking lots actually don't even respond to that public, and they assume a blame.
That's true.
Most parking lots are pretty uneven.
You brought up an interesting question, the SCS curve number method, for example, but they use this mostly for ungauged watershed. What shall we do if we have to develop something for an ungauged watershed, which cannot calibrate since we have no data?
Well, there are two approaches to that as far as I'm concerned. One is to use a model calibrated on a similar basin and transfer the parameters with your necessary judgment. And the other is to try and calibrate something else. I think it should be noted that there are very few jobs that have to be done so fast that you can't afford the time to get a year or two of streamflow records in a bit of rainfall. And if you got that much, you can use a model. Unless they happen to be totally dry years. But most people don't want to do that.
And they don't want to spend the few bucks it's going to take to collect a little bit of information.
Or the time.
For the time.
Yeah.
What do you think of, along the same line, of the future in hydrology? You see that a lot of progress being made in the next few years, or?
Oh, I'm sure there'll be a lot of progress made. When I look back over 49 years, you see what progress has been made. You can't think it's going to come to a stop. I don't know that there's too much thought been given to how it's going to come about the future. And I'm sure a lot of the lines of research that are going on right now will never produce any useful answers. But I think you have to decide what the problems are and set about the researching. For example, I think we still have a terrific problem in flood frequency.
Yes.
We don't even know what kind of a distribution should be used. And we have no way of getting at it. The conventional method of fitting distributions to curves and then running a statistical test to see which one fits best. And some work we're doing here at Linsley Krieger Associates now involves generating about 10,000 years early rainfall data, and running that through a deterministic hydrologic model to get 10,000 years of streamflow data. This is not intended to represent the past 10,000 years because we know that various climate changes in that period, but it gives us a sample which may tell us something about distributions that fit and distributions that don't fit. Also, it might just give us a clue to the probability of the probable maximum flood.
Yes.
Or the probable maximum storm.
And this was one of the things we discussed yesterday, is that we don't have a good way of assigning this. And, I was on a committee it was an ASC committee back in the 60s. And I think you may have been the management group D or whatever it was representative about that time.
So.
That'd have been after the time that you were. Yeah. But at any rate, that was one of the big problems we had was looking at the probable maximum event in some kind of a sense of risk or probability. We don't have any good way of handling this. Mm-hmm. So it makes it very difficult when you do economic analyses or anything to come up with any kind of answer. Yeah. And you're absolutely right. What you're talking about may do that.
That's an expensive kind of research, of course, because, we have to let our computer over at LKA run for a week.
We have a small one.
It's a little bigger than a IBM PCAT.
I see.
But it takes a long time to run out 1,000. We've been 1,000 years. So far, we've only done 1,000.
I see.
But this time we're going to try for 10,000.
Are you doing, I know you formed this company when, in about 80 or?
January 79.
79. Are you doing consulting work in hydrology primarily?
Yeah, we've been doing work. Much of it right around here. We install stream gauges and all rain gauges. We try to help out the local water districts in studies of their reservoirs.
I see.
We do some hydraulic work too, of course. I did a check on the storm drainage of Shubail in Saudi Arabia.
Oh, is that right?
Incidentally, if you want to talk about a parking lot, that's it. 100 square kilometers of parking lot.
Wow.
It's all paved.
Is that right?
Yeah.
The whole? Good night.
Okay. Well, one storm that had been observed in Japan.
And tried to estimate what kind of a flow it would produce. This is quite a large flow from 100 square kilometers of pavement. The drainage ditches there were 40 meters wide and 10 meters deep, something like that.
Pretty size, really, pictures. Don't run very often, though, do they?
No. They're good sand traps, so.
Ah. But that's true.
No, I think I would not have built one that big if I got the original job. I was just asked to check the design.
Oh.
And mostly they were over-designed, I thought.
Was this a project that Bechtel was involved in?
Bechtel was they were the coordinators on the court. They didn't do any of the original design, but they coordinated the whole thing.
Oh.
All of the various subs, and So I was hired by Bechtel to check the design of another firm.
I see. Because I talked to Jack Cassidy about that, some years ago out in Steel with the Weather Service. He was trying to get some data, which we didn't have, of course. And he called me up. And the data must be very sparse from that part of the world.
Oh, it is. There's a long record on the one island where the oil production has been going on for a long time.
Bahrain or
Bahrain?
Bahrain.
Like it's Bahrain, yeah.
Bahrain.
But most of the countries over there don't even have a rain gauge.
Yeah.
And I don't know any stream gauges.
In Saudi Arabia, I don't think they need them. You have some other questions?
No. I was still, again, if we have to formulate a program, for example, in hydrology in the largest sense with groundwater, surface water, and so on, what areas, rather than areas, let's say, how should the distribution be between basic theory, engineering, application? How can we teach those things?
Well, no, I've written 2 books, and a lot of people have read them, but I don't see a lot of the people that have these in their bookshelf make some of damnedest mistakes. So the question of how you teach it is a real hard question to answer. I believe that it's essential that they understand, as well as we understand, the processes that are going on out there. We still don't really understand what interflow is, but we know it occurs. And there are a lot of other things we don't understand in full scope. But I think that should be covered in considerable detail. That's as far as surface water is concerned. Groundwater, I think, maybe is best on a case study basis. With a lot of case studies of all sorts of things that have been observed. And I think they should do a lot of problem work on real problems, not necessarily jobs that have, for example, not necessarily a reservoir or dam that's going to be built, which you can pick a site and bid in the data, or they can get the data from the survey, which is what they'll have to do anyway, and work out a solution. And I think it would be helpful in those cases to have 2 or 3 teams working independently, to see how different their answers are
On the same project.
in the same project.
Yes. Yes. And that might be very informative and instructive.
We did that at Stanford one year. We gave them all a storm drain problem down in Hollister, Gilroy, somewhere. And one told them to go ahead and solve it. Use any reference they could find, any method they wanted to. And the spread was unbelievable. It shocked both Crawford and myself, the size of the spread. And I'm sure it got the point over the students that some of these couldn't possibly be right.
I think that's true. It's a good way to demonstrate you can get very different answers starting with the same assumptions.
I think you can take a model like the Stanford model and set it up, let students play with it a bit, let them change parameters, assume a different evaporation, assume different rainfall, or rainfall 10% higher, 10% lower, and see what impact it has. It'd be very interesting. I know people still don't believe that you can use pen evacuation data in any way in a model. And we'll try to fit in some kind of an equation. Well, if we can go and have pen data on, I'd use an equation too. Pen data works.
Yes. It's real data.
Yeah. I think students need to be disabused of the idea that you can have any kind of a model that will lead to an absolute answer that's even close to right without calibration. And they need to understand, too, that calibration means more than just running one flood through it.
Yes.
I'm still not sure whether you're automatic.
Calibration.
Well, it works, but I guess it's a good way to get started.
That's true. It's a good way to get started, but actually that's all. Yeah. I just returned from China recently, and the Chinese were using the model that, this group IHS, I don't know whether you ran into any of those chaps or not. They work with Sierra Misco. Up and they put them in these automatic rain gauges and things. Well, they're using a form of Weather Service program. And the trouble the Chinese were having is they couldn't calibrate it. Mm-hmm. And, I don't care how good that data is. If the model isn't calibrated to the basin, you get garbage. Yeah. And you're absolutely right. It's the real problem. Well, I think we should, yes. We appreciate it very much, Ray. We've taken a lot of your time, longer than I expected. But I'll tell you, you've really filled me in on some past in the Weather Service that I wish I knew a few years ago. In fact, I ran into a chap today, Ron Lavoie, who works for the Weather Service now, and he was telling me that Dick Haldren is in the process of he's going to have to give a talk sometime in January, and one of the things he wanted to do was to bring in some of the past history of the Weather Service, the hydrologic program in the Weather Service. And the trouble is, he started going back and trying to find that information. I can't find it. You know, you can't even find out who the people are.
This Winston still around?
Ben?
Yeah.
I don't think so. I think he's dead.
I was afraid I'd heard that.
Yes. And you know, Showalter died just very recently.
I saw that.
Yeah. But I think Swenson, yes, I know he did. He died not too long ago.
Yeah.
But of course, Max is still available, and Max has a lot of that history also. And of course, Bud Hyatt is still around. And you know, his wife died, though.
Yes, I did.
Been about a year ago, I guess now. But
Yeah, it's scary when all these people your age drop one.
well, it's what happens. I mean, you know, eventually you reach the point that you don't know anybody except the younger ones.
Yeah.
And
It wouldn't hurt to get together with not Max, but Joe Paus.
yeah, oh yes, very definitely. Somebody should get to Joe.
He started it in the Weather Service at Boston in the airport station there. He's got tales about that.
Yeah, I talked with John Miller yesterday, and he is willing to do this. Is there anything if we get in touch with?
Oh,
we'll do that.
very definitely, because Joe's getting quite frail, and but Joe's mine. But Max said they were going to come out here. We could get him someday in Shanghai. Maybe we could get him. I don't know who I was talking to, but they had it wrong. They said, oh no, he was at Sacramento, and then he just moved on over to Stanford. And I said, I don't think that's right, but I wasn't sure. So, okay.